Mercury, frequently a speck contrasted with behemoths like Mars or Jupiter, currently conceals earnest mysteries beneath its surface. Researchers, utilizing powerful telescopes, have coincidentally uncovered these secrets. They are witnessing something move that they have never noticed elsewhere. These discoveries could lead to significant missions to uncover a startling truth about our universe. We are not alone. We must expose the dark shadow that Mercury has kept hidden. This small, swift planet travels around the Sun faster than any other in our solar system, completing its orbit in just 88 Earth days. Historically, our understanding of Mercury was limited. Early astronomers had little more than basic telescopes to study it, and the planet's small size and rapid orbit made it a difficult subject to analyze. It was only when space exploration advanced significantly that scientists began to get a clearer picture of Mercury. NASA's missions in the 20th century provided the first detailed images, revealing a landscape marked by craters. These images were just the beginning. Recently, improved data from space telescopes have suggested that there may be unusual features beneath Mercury's surface, sparking a flurry of academic interest. This interest has ignited both excitement and a fair amount of skepticism within the scientific community. Some researchers, buoyed by the new data, speculate about groundbreaking discoveries on Mercury, possibly related to geological features or other previously unknown aspects. Discussions have begun about more ambitious projects to study Mercury further. These plans aim to explore the planet more thoroughly, potentially uncovering new information that could reshape our understanding of the smallest planet in our solar system. There is a sense of anticipation, but also a need for caution, as these plans could lead to more invasive investigations that might disrupt the planet's natural state. Amid this renewed focus, it's important to remember the broader context. Every planet in our solar system, including Mercury, has its own unique characteristics and history, which can provide valuable insights into cosmic processes such as planetary formation and the effects of solar proximity. As scientists propose deeper explorations of Mercury, they must balance their enthusiasm for discovery with consideration for the long-term implications of their research. Uncovering new knowledge is exciting, but it's crucial to proceed in a way that respects the intrinsic value of Mercury's environment. Studying Mercury proves to be quite a tricky endeavor, akin to trying to take a clear photograph while staring into a brilliant spotlight. Despite years of careful planning and advanced technology, scientists find themselves hindered by Mercury's proximity to the Sun. The Sun's intense light and heat not only make it difficult to observe the planet, but also pose a serious risk of damaging delicate instruments such as telescopes. As a result, astronomers can observe Mercury only in short bursts to avoid harming their equipment. Even the powerful James Webb Space Telescope must avoid pointing too close to Mercury for fear of solar-related damage. The challenges don't end with visibility issues. Sending a probe to Mercury is almost like sending it on a kamikaze mission. Any spacecraft that ventures near must be heavily shielded against the planet's extreme temperatures and the Sun's powerful gravitational pull, or risk being destroyed. This makes missions to Mercury rare and brief compared to other planetary explorations, which often involve longer visits. Mercury speeds around the Sun at 30 kilometers per second, making it the fastest orbiting planet in our solar system. This incredible velocity complicates tracking and studying Mercury and presents formidable challenges for any mission attempting to land or orbit closely. To date, only 2 missions have bravely targeted Mercury. NASA's Mariner 10, launched in 1973, and Messenger, which followed about 31 years later in 2004, are our primary sources of first-hand information about the planet. Mariner 10 was equipped with advanced instruments such as telescopes, spectrometers, a magnetometer, and a plasma analyzer, essentially making it a mobile science lab tasked with gathering as much data as possible during its rapid flybys of Mercury. The probe cleverly used Venus' gravitational pull to adjust its trajectory toward Mercury, allowing for multiple flybys that revealed the planet's surface for the first time to us Earthlings. The images returned by Mariner 10 unveiled a landscape full of craters and strange ridges, much like those found on our Moon. This suggested that Mercury had a rugged and heavily cratered exterior, along with a surprisingly strong magnetic field and a larger core than previously expected, challenging scientists' prior assumptions about its composition. During its second flyby in 1974, Mariner 10 captured views of Mercury's southern polar region, offering new vantage points and data on this difficult-to-study planet. The mission concluded with its final flyby in March of the following year, providing even more data but leaving scientists wanting more comprehensive information, a desire complicated by the technical and environmental challenges of studying Mercury. To date, most of what we know about Mercury comes from the 2,700 images and scattered instrumental readings from these missions, a remarkable achievement given the circumstances, yet also a stark reminder of how challenging space exploration can be. Every piece of data from Mercury is hard-won, serving as a small triumph over the vast and unforgiving conditions of our solar system. It highlights how our pursuit of knowledge about our planetary neighbors is often constrained by technological limitations and the harsh environment of space. Thus, studying Mercury not only satisfies our thirst for knowledge but also reminds us of the inherent difficulties of probing the universe. Every new discovery is a step forward, but it underscores the slow and painstaking nature of uncovering the complexities of planets like Mercury. Next, we explore what happened after Mariner 10 and how its legacy paved the way for new missions, further investigating this enigmatic terrain. When the Mariner 10 spacecraft ran entirely out of fuel in 1975, its mission ended, leaving it to drift silently through space. This marked the end of an era but also set the stage for its successor, NASA's Messenger, which launched 30 years later. Unlike Mariner 10, which only conducted flybys, Messenger had a more ambitious goal. It was designed to enter orbit around Mercury. This mission aimed to do much more than just take pictures. It sought to dive deep into understanding the planet in ways never before possible. Mercury's air, its synthetic cosmetics, and its actual elements, furnished with the most recent scientific equipment, were studied by the Courier mission, which was entrusted with uncovering the detailed qualities of Mercury. NASA's objective was clear: to gather an abundance of data that would offer insights far beyond the surface layers of the planet. This probe was designed to explore every aspect of Mercury, from its magnetic field to the geological and physical structure of its core. The mission was not just about capturing images. It was about comprehensively mapping and understanding Mercury. During its mission, Courier made 3 critical orbits around Mercury and took an impressive 200,000 photos. These were not just ordinary pictures. They captured detailed views of Mercury, including areas never seen before in past missions. The data revealed fascinating details. For example, there were unusually high levels of calcium and magnesium on Mercury's darker side. This discovery likely raised questions about what processes contribute to such concentrations. Moreover, the planet's magnetic field was found to be unusually strong in the northern regions, which was uncommon compared to other planets. As NASA analyzed the data, it became clear that Mercury's unique magnetic field was due to its internal structure and formation history. On most planets like Earth, magnetic fields are generated by the movement of liquid iron in the core. As the planet rotates, this liquid iron moves, producing electrical currents, which in turn create a magnetic field. However, Mercury's internal structure is different, leading to a distinct magnetic behavior. The findings from the Courier mission are significant because they offer a deeper understanding of Mercury. This isn't just about gathering data for its own sake. This information helps scientists understand how planets form and behave. It challenges past assumptions and provides new insights that could be relevant to other celestial bodies. The story of Mercury's exploration is one of human curiosity and technological advancement. The journey from Mariner 10 to Courier showcases our progress in space exploration technology and our expanding understanding of the solar system. Each piece of data that Courier sent back to Earth not only added to our knowledge of Mercury but also helped us rethink our own planet. By studying Mercury, we learn more about the universe and our place within it, highlighting how interconnected and complex the cosmos truly is. As we continue to analyze and understand the data gathered by Courier, we build on the legacy of past missions. Every discovery contributes to a growing body of knowledge that informs future explorations. The story of Courier and Mercury is a testament to the enduring human spirit, our desire to explore, understand, and continuously push the boundaries of what is known. Unusual discoveries on Mercury. HOA, from the University of California, Los Angeles, found something strange about Mercury that has puzzled many scientists. Generally, in planets like Earth, iron transitions from liquid to solid at the deepest part of the core. However, on Mercury, this change happens at the outer boundary of the core, which was unexpected. This finding challenges previous assumptions about how terrestrial planets behave and suggests that Mercury has a unique way of functioning. To explain this phenomenon, HOA compared it to a snowstorm where snow forms at every level of the cloud, not just at the top or bottom. This means that on Mercury, iron might be forming solids throughout the liquid surrounding the core, affecting the planet's magnetic field in unexpected ways. This discovery has profound implications for understanding how magnetic fields are generated on different planets. It suggests that the same fundamental ingredients can produce drastically different results under varying conditions. Further research, supported by data from NASA's Courier mission, backs HOA's findings. It appears that despite having similar elements like sulfur and iron in their cores, Earth and Mercury behave differently. This raises intriguing questions about how magnetic fields can form on planets, suggesting that what we have learned from Earth might not apply universally. Mercury's extreme conditions. Mercury's unusual characteristics don't stop at its core. The planet's surface experiences extreme temperature variations that are astonishing. During the day, temperatures can reach a scorching 430 degrees Celsius (806 degrees Fahrenheit), while at night, they plummet to a freezing -170 degrees Celsius (274 degrees Fahrenheit). These drastic changes are due to Mercury's nearly non-existent atmosphere. Unlike Earth, which has a thick atmosphere that regulates temperature, Mercury has only a thin exosphere, composed of atoms knocked off the surface by impacts from space debris. This thin exosphere does little to protect the planet from temperature extremes or retain any heat. It is so insubstantial that it's barely there at all, contributing to the harsh conditions on the planet's surface. This aspect of Mercury further differentiates it from Earth and challenges assumptions about planetary atmospheres and their effects on surface conditions. Insights into Mercury's environment provide a clearer picture of just how diverse planets can be, even within our own solar system. Each planet operates according to its own set of rules, shaped by its unique composition and environmental factors. The study of Mercury encourages us to expand our understanding and consider that the behavior of other planets could differ significantly from Earth. Mercury's unusual rotation and orbit. Mercury's extreme conditions go beyond just temperature. A year on Mercury is shorter than a day. One full rotation of Mercury on its axis, which defines a day, takes 176 Earth days, while a Mercurian year, the time it takes for the planet to orbit the Sun, is only 88 Earth days. This phenomenon leads to one side of the planet being exposed to the Sun's heat for long periods, while the other side experiences an extended, freezing night. The idea that any form of typical Earth-like life could survive in such conditions seems highly unlikely. Despite this, Mercury's harsh environment has sparked much discussion and speculation among scientists. Could life exist on Mercury? Although Mercury's conditions appear inhospitable, its surface features, such as impact craters, have led some scientists to speculate about the potential for life, at least in some form. These craters, similar to those on the Moon, sometimes contain shadowed regions that never see sunlight. Could extreme life forms exist in these permanently shaded areas, taking advantage of minerals in the rocky soil? Speculation about life on Mercury often requires thinking far beyond conventional biology. Could there be organisms that thrive on radiation? Could life exist without water? These questions push the boundaries of current scientific thought and delve into more speculative science. However, the ongoing interest in Mercury is not just about finding life. It is about understanding the limits of planetary environments where life could exist. The mystery of Mercury's magnetic field. As scientists continue to analyze Mercury's mysteries, data from past missions like Courier are still being reviewed, leading to new insights that may take years to fully comprehend. One area of intense interest is the planet's magnetic field, which remains a subject of debate among experts. Unlike Earth's magnetic field, which is generated by the movement of liquid iron in its outer core. Mercury's magnetic field is believed to be influenced by a solid inner core surrounded by a liquid outer layer. This unusual structure may explain why Mercury's magnetic field is weaker than Earth's but still unexpectedly strong for a planet of its size. Geological activity on Mercury. Despite its small size, Mercury shows signs of tectonic activity. Evidence of massive faults and ridges across its surface suggests that Mercury has undergone significant contraction as it cooled. These geological processes, while not as dynamic as those on Earth, provide valuable clues about how rocky planets evolve. Researchers are also exploring the possibility of volatile materials beneath Mercury's surface, which may have been trapped by its unique gravity and lack of atmosphere. Studying these volatile substances could offer insight into the conditions that existed in the early solar system, adding another layer to our understanding of planetary formation. Conclusion: Mercury continues to surprise scientists with its unusual characteristics, from its magnetic field and core structure to its extreme temperature swings. Each new discovery challenges our existing models of planetary science and pushes us to reconsider our assumptions about how planets form and behave. As we continue to explore space, Mercury serves as a case study for the unexpected, reminding us that planetary science is full of surprises. The more we study Mercury, the more we learn, not just about our solar system but about the universe as a whole.